there's some, yeah, there's this type, and then there's the one where it's like the number other than one for X, like for number example,
Those are
number
those are the
two.
more those are the more challenging ones here. Let me take a look. Yeah. Okay. So like for example, number one is great. Number four is like number one. And so like just being able to identify the type is really important here. Like I don't know if you want to do a couple in a row of the same type, but four is the same type as number one. So
Except instead of using X, they just use Y. So then you'd be
yeah, the
Y
variable, and
minus.
if you don't like it, just change it to X. Just be like, all right, yeah, there's my problem. That's okay. Why don't you try this one? How are you doing on this one?
So I can gain the wait, actually. Wait, so for this one, wouldn't -2 and 8 be the
Has to add to -6.
uh and
Yeah, so that
be
operator goes with it.
so -8 comma 2?
Well, yeah, you just say the
Because
two numbers and then you write x minus 8,
yeah,
x plus 2, and then you really should switch back to the original variable. Um,
yeah, so then Y-2. Got it. So the sign of the middle number coefficient, guys. So you keep that,
multiply the last,
then
add the
add it to
middle.
the. Got it. And then in this case, it would be X minus 8, X plus 2. Okay. Um, mm, yeah,
Okay, is that clear?
yeah.
Okay, so um, just so we can get through all of these, I'm just going to go through the list here and tell you the ones that are like this. So 8 is like this, 13.
Yes. So then 7 would also be like the.
7 is actually a different type we're going to talk about next, believe it or not. I know it's um 18 is kind of like this. It's got a little other little wrinkle to it. This like the problem with the way they're
Yeah,
presenting this
18 is
homework.
like the, yeah, 18 is the, without the one in the, as a,
It's got a
six,
GCF.
yeah,
It's
GCF.
actually got a GCF, and that's why it's different. 22 and then 23 are like these. And identification is really important here. So the next type of problem that we're going to do is what's called a perfect square trinomial.
Yeah,
These have
yeah.
the appearance of being a equals 1, but they are not. And that's when you were saying, hey, let's do 7. 7 is actually a perfect
Oh, yeah,
square
it's,
trinomial.
yes, yeah, no.
Now they can be
'Cause-
done exactly the same way that we've been doing, but it's really good to recognize that the square root of 49 is 7. 7 doubled is 14, and that's the middle number
yeah,
right there. So
7
when they're
is 14, and then
what
7 times 7 is 49.
yeah, so these become a plus b squared. So it ends up becoming in your problem here, k plus 7 squared like that. Sometimes you write them like this, k plus 7 times k plus 7. It does not matter to me because, of course, I'm not grading you, but you might ask which they prefer in the classroom here. Actually, 12 is kind of like this, but it's got a GCF in it. All right. So let's do another perfect square trinomial. 15 comes to mind here. So why don't you try this one? It's this formula here. Let me know what you come up with, please.
That's 15.
You have the answer for this one? Karthik, are you still there?
Yeah.
Okay, how are you doing on this one?
I didn't get the, so I tried doing x squared plus 4x plus 4x plus
No, no,
16.
no, no, no. This is the perfect square trinomial. Perfect square trinomial. You take the square root of the last, which is 4, and if it's doubled, becomes the middle one. That's a perfect square trinomial.
Uh,
So this
right.
becomes just x plus 4 squared like
So then
that.
you wouldn't have to do all this. You just put it's x plus 4 times x plus 4, x plus 4 squared.
Right.
Got it.
Okay, now what you're looking for a perfect square trinomial is you actually have to be able to take the square root of the first as well, but we'll get to that when it becomes appropriate. You have to be able to take the square root of the first and the square root of the last. Now, I feel like I should give you another one of these because they're not giving you all the possibilities. Like, let's say it's x squared minus 10x, sorry, minus 20x plus 100. Okay, this is a perfect square trinomial. Okay, now when you take the square root of 100, that's 10. 10 doubled is 20, and you might say, well, wait, that's not 20, it's negative 20. I'd be like, you're right. You are right. There's two forms of perfect square trinomials. There's a squared minus 2ab plus b squared, which is the one we have here. It becomes a minus b squared. And then there's the one we've been doing, which is a squared plus 2ab plus b squared equals a plus b squared. So it is okay. It is okay for there to be a negative. This becomes x minus 10 squared like that.
Got it.
But you have to know both of these formulas. So note cards, Quizlets, whatever you guys are doing nowadays to remember stuff.
Yeah, probably important to know all the forms. How to factor them. All right, nice. So if it's a minus 2ab, then oh right. Yeah, I remember this from algebra. Or if it's minus 2ab, then all right, yeah. So if it's minus 2ab, then it's a minus b squared. If it's plus 2ab, then it's a plus b squared. All right, yeah. Yeah, got it. Huh. Yeah, so for example, for this problem, yeah, so 10 would be it because 10 times 10 is 100 and
Yeah.
10 is plus 10.
Yeah. So let me give you a couple more here to try. Go x squared minus 6x plus 9. This is again a perfect square trinomial.
That would be x minus 3 and yeah, x minus 3 and x minus 3
Good,
is
really
the
good.
perfect square.
Yes. All right. Now the next type is going to look really similar, but it's different. And the thing is what's hard about these is that they're not that hard when I tell you like what it is. I tell you, oh, this is difference of squares. It's hard when you're getting them all mixed together. So let's look at 11. 11 is a difference of squares. So you'll notice in that little cheat sheet reference guide you got that difference of squares is always two terms, and there has to be
Wait,
a negative.
so for example, so For example, if you're taking number 11, it would be x squared minus 9 squared.
Yes, you have to figure out what squared minus what squared. So in this case, it's
Yeah,
x is being
so
squared and
it's
9
the
is being
first,
squared.
so yeah, so is it always going to be like x squared minus something, or can it be like a
It
number squared?
it could be a number like here's a problem. Like we could do 1 minus x squared. This would be totally valid. Um, the order does not matter.
Got it.
So the formula here for difference of squares is that you typically have an a squared minus a b squared. It becomes a minus b, a plus b. So it looks really
Yes, we talked
similar to
about
what
that
we,
in class. Yeah,
yeah. So you have to figure out what a is. A is the thing that you're squaring. B is the thing that you're squaring.
got it. And then since you turn the negative 81 into minus 81 into minus 9 squared, you already have the a minus b
Right,
squared. Now you need to take the a minus b and turn it into the dot. So yeah,
right.
and just
So it
so
becomes
this would be
x
x
minus 9,
squared.
x plus 9. The order does not matter. So if you end up going and putting in if you do x plus 9, x minus 9, that's okay too.
Got it.
So
Uh,
the goal is to figure out what is being squared, what is being squared,
got it.
right?
Yeah.
So now we're going to work on a couple more like this one. So let's do 16 next. Like you to try 16. It's another difference of squares, just like what we did.
Okay.
So like I said, yet another formula. Remember, a lot of formulas, a lot of formulas. Just keep that in mind here. Give this one a try, please.
All right. I got x minus 8 times x plus 8.
You are correct. Let's see if there's any others on that page. 24 is a repeat of one we already did, x squared minus 81. And then we'll go back and we'll do
X
number
squared minus
3.
81. That'd be x plus 9 times x minus 9. Because yeah.
So hopefully you got x minus 9, x plus 9 again.
Yeah.
Okay, now number 3. Whoa, that's not what we want. That's what did that snip in? Okay, I don't know. Number 3 is 4x squared minus 1. So this one's a little bit more difficult. Um, you have to remember that 1 squared is always 1, but in the first position here, you have to get back to 4x squared. So to get to the 4, 2 squared gets you to 4, x gets you to x squared. So what you're seeing here is that a can be more than just a letter or a number. It could be a letter and a number.
Got it. So x minus.
Okay, so this becomes,
Got it. So then that would be 2x. Yeah. So you just pretty much, instead of putting x, you would instead of putting x, you would look for the x and the coefficient.
so what it could be here, so let me give you a more complicated one. This is 9x squared minus 16y squared. You have to figure out what it is squared minus what it is squared, like that.
So for the first one, first one would be 9x.
Nope, because you're squaring. It's both the number and the letter, should be
Uh,
3x.
oh. Then so that means for the other one it would be 4y.
You're right. You got it.
Got it. I thought it would just be the a and the x and the coefficient. But yeah, so you got this both. All right.
Okay. So like you said, it'd be 3x minus 4y times 3x plus 4y, like that. Like I keep saying, that the challenge is really when you're trying to do them all together, like knowing what they are. So the next one, it may not make sense at the moment, but we're going to do number 5 next. That's grouping, comes
Yeah,
before.
I think it talks about that on the sheet too, the four terms by grouping.
So this is grouping. You look at the first two terms and you find what's called the GCF, or the greatest common factor.
Yeah.
So you look at the number and the number. 2 goes into both.
Yeah. So then it
And
wouldn't it be 2y squared?
yes,
Oh,
and then
yeah.
you're effectively dividing both of these by 2y squared to figure out what goes in parentheses. You remember that from class?
Yeah, except I don't think divided it by 2x squared, just the
Yeah, I mean, you just have
the
to figure out what it is.
yeah,
It's sometimes
yeah,
called divide and slide, and it doesn't
yeah.
matter what you
So
call it. It's
this case, since we already took out the y squared, would it be y minus
1.
1? Yeah, because we already took out this y squared. And then
Now,
other
now this is
side,
important. You immediately write what's in parentheses over here off to the right with a little space in between.
because it has to be the same in order for it to
Yeah. And then you figure out
match.
what goes here
That would have
such
to be
that when you
3 in
multiply
this
in,
case.
yeah, it'd be plus 3 in this case. Now it's called grouping, but I think a better name for it is double factoring or multiple factoring, because you end up factoring twice. These both, there's actually 2 terms here. This is term 1, and then this is term 2. And they both have a y minus 1 in it. So that's what you factor out of both, y minus 1, and then 2y squared plus 3 is what's left over.
Got it.
So we should do another one because these are the most
Y
difficult.
2y squared. Okay. Um, I think number 9 is the same or kind of form of yeah.
Yeah, let's do number 9. A good eye on that. Let's do that. It's a little bit more complicated. Let me see if there's a less complicated one for us to do first. Yeah, let's do 17 first, and then we'll go back
All
to
right.
the 9. For whatever, you got to be careful here about how you do these, because they can be way more difficult than they need to be in terms of your learning. So again, you're looking at the first 2 terms. You figure out what's common between the first 2 terms. And I think you would say it's x squared.
Yeah,
So what goes in parentheses here?
x minus 9 because it's when the other side has to be x minus 9
Right.
too.
And then
And that would
and
have
then
to be
it's
plus 1. Yeah, because it's already an exact form that we need it.
you keep going. If you notice the instructions say factor completely, the more you do these, the more you'll see that, when you actually stop, but
So in this case, yeah, it'd be x minus 9 and then x squared is 1.
good. Okay, so now we can go back and do number 9, which is very similar.
And,
So you look at the first two terms here, and there's an x that's common between them.
yeah,
So what goes in parentheses?
that would be 3x. Okay, so only one more x for the x squared minus 4.
Good. And that
Or so it
immediately
has to
goes
be the
over here.
same.
And then
3x.
you have to figure out what goes here. So it's both a number and a
Yeah,
letter
it's
this
good to have
time.
the y because this part was on the y. We need the y. But we
What
also
about the number? What should that be?
need, it would be a frac. Actually, no, it wouldn't be a.
You have to multiply and to get 3x goes to 9x, 4 goes to 12y.
Yeah. Oh wait. Um, you can. You can do 3y.
3y, good. So then you factor out this here.
3x minus 4 and x plus 3y.
Again, order does not matter, meaning that if you put x plus 3y, 3x minus 4, this is also good.
Um,
All right, so now we're ready to do a problem like 2. 2 turns into a problem like 9. So we're gonna do that first here.
so, yeah, so choose 3 terms.
3
Uh,
terms. First one is not a 1. And the problem here is that 2 doesn't go into the other ones. Like it's not a GCF. So this is what I call the A not equal to 1. It turns into
yeah.
grouping. And what you do is you take the,
Wait, but on here it says that you're supposed to find the factors of a times c and then
so you
add
take
that up to the
2,
factors of
you take the coefficient up front and multiply it by the last term here
yeah.
to get -6. And now what you're looking for is 2 numbers that multiply to -6, but add to -5.
Negative 2 and 3. Actually, no, negative 3 and 2. Yeah, okay, yeah. But
So
it needs to add up to
-5. So
um
like 1 and -6, -1 and 6, 2 and -3, -2 and 3. Do any of those work? Did any of those add to
mm,
-5?
-6 and 1 would because
Right.
-6 plus 1. So
So now what you have to figure out, and this is a little harder, is which pair's better with 2x squared? Is it -6 or is it +1?
it would be +1.
So I disagree. I disagree here. What we're doing is we're breaking apart the -5x into this. And because we want to do a GCF factoring, I think the -6 pairs better with the 2 because they both are divisible by 2. The way you were suggesting does work. It's just that there's kind of a preference.
Got it. So
So
plus
now this again, this is just like the ones we were doing. You had to figure out the GCF of the first 2.
that would be 2.
2x.
Then the inside would be x
2.
minus 3
Yep. And then x
this
minus 3. And then what goes here so that when you multiply in, you get back to x minus
positive
3.
1.
+1. Good.
Then that would make the factors x minus 3 and 2x plus 1.
Good. All right. So, um, let's see if we can have you do another one like this. Six is our next one that looks like this type. Let's take a look here. 6 is 2x squared plus 17x minus 9. So again, it's an a not equal to 1. This right here is not 1, and 2 doesn't go into the other ones. So you know that this leads to grouping. And so you take
Yeah,
the 2 and multiply it by the minus 9. 2 times minus 9 equals minus 18. You're looking for two numbers that multiply to minus 18, but add to positive 17.
-1 and 18.
Okay, so that worked. Now, which pairs better with 2x squared? -1 or 18?
18.
Yeah, even if you don't believe it, you got to go with it.
Yeah, because so does it like the bigger number goes
No, it's the
first?
one that like has the same greatest common
Oh,
factor, typically.
the same grade.
Yeah.
Got it.
Okay, so why don't you finish off the problem from here
Good.
and let me know what you come up with.
Squared plus 18x. All right. 2x. Okay. All right. I got x plus 9 and 2x minus 1.
Okay, we haven't talked about this yet, but here's how you would check it. Like, let's say you're on a test and you're like, I wonder if this is right. You would FOIL and you would hopefully get back to the original. And guess what? You do. Very good. All right, so let's have you try one start to finish on your own. 14 is the next one. Um, it is another grouping problem like we've been doing. So give this one a try. Let me know if you have any questions as you work it out. How are you doing, Karthik?
Um,
Any questions for me?
Not yet.
Okay. Did you get -2 and -12 as your separators for this?
For -2, I got 22.
No, do they multiply?
Oh,
Multiply
to
these.
multiply
Yeah.
it.
Yeah. So let me just it is this is the separation of it. So um
Uh, got it.
all right, let's try it from here. See what you come up with.
So 3x squared minus 12x plus 8. All right, almost done here. And we have x minus 4 times x times 3x minus 2. Yep.
Like that? Was that how you have it?
Yeah.
Okay. So typically the one with the higher or bigger coefficient comes first as like a preference, but they're both correct here. Let's just FOIL it and make sure it works. 3x squared minus 12x minus 2x plus 8, which does in fact lead to back to the original. So you can actually always guarantee that you have the right answer if you have enough time to FOIL it to get back to the original. Okay, let's quickly look at a problem like 10, which is kind of different. We don't have a ton of time here, so I'll just quickly run through a few of these. So this one has the appearance of the ones that we've been doing, but the 2 in front of the x squared goes into everything. And when you factor it out, you always factor out a GCF first. This
Yeah.
becomes an a equals 1, ends up being x plus 2, x minus 1 with a 2 out in front. You got to be careful that you don't try to use the approach that we've been using on these, like 2 times -4. While it does work, it leads to extra steps that will cause you challenges. All right, number 12 is really similar. The 3 comes out, x squared minus 2x minus 8. Always try a GCF first. This is an a equals 1. Ends up being x minus 4, x plus 2. Don't forget to bring that coefficient down like that. So I think that covers most of your assignment. There's some problems that we did not get to, but hopefully it's enough for you to be able to work this out on your own. I assume this is due tomorrow.
Yeah.
All right. Do the best you can. And keep in mind it's a holiday weekend coming up here, so